All right, kiddos, today we're going to look at balancing chemical formulas and the law of conservation of mass. So just a quick review. Remember that these are models of a chemical formula. In this model, you can see you have two elements. I have aluminum and oxygen. I can see that there are 5 total atoms, and I know that there are 2 Al atoms, and I know there are 3 oxygen atoms. So my formula, if I were to write this out, would be Al with a little subscript 2, big capital O for oxygen, and a little subscript 3. So this right here is the chemical formula that is matching this model here. All right, let's try another one. So here's the model. I see I have 2 elements. I have aluminum and I have chlorine. So how many, if I were to write the chemical formula, how many aluminum atoms do I have? 1. So do I have to write the 1 or is it assumed? It's assumed. How many Cl's or chlorine atoms do I have? 3. So I would write the little subscript 3. And that would be my chemical formula to match this chemical model. All right, last one here. Again, how many elements do you see? I see 3 elements. I see hydrogen. And how many atoms of hydrogen do I have? 3. I see phosphorus. And how many atoms of that do I have? 1. It's an understood 1, so do I have to write the 1? No, I don't. And then I have oxygen. How many atoms of oxygen? 4. So I would write a little subscript 4 here. So that's the chemical formula for that model. You will see the bottom 3 on a worksheet coming your way in your very near future. If you need to pause the video and test yourself out, see if you can do those 3. All right. In the formula 4NH3, what is the coefficient? Remember, the coefficient is the big number in the front. The coefficient is the 4. It tells me that I have 4 NH3s. The subscript, the little word sub, like a submarine goes under the water, a subscript goes under the letter. So the 3 is smaller or beneath the letter there. So subscript would be 3. How many elements are in this formula? Well, I have nitrogen and I have hydrogen. So I have 2 elements in this formula. And then finally, how many atoms of nitrogen are in this formula? Well, I only see 1 N, but there's 4. The coefficient is in front of it. So remember, the coefficient means that you're going to multiply your coefficient times your subscript to find the total number of atoms. So the understood 1 times the 4 gets me 4 nitrogen atoms. Same way, how many hydrogen atoms are there? Again, use your formula. Your coefficient. 4. Multiply it by the subscript, 3. And that should get you a total of 12 hydrogen atoms. Go ahead and pause the video. See if you can answer those questions. Again, you're going to be seeing those on a worksheet coming your way soon. All right, moving on. So now we're going to actually practice doing some balancing of these chemical equations. So this whole thing right here is a chemical equation. It is made up of chemical formulas. There's 2 chemical formulas here on the left, 1 chemical formula here on the right. Now I know on the left side of the chemical equation is my reactant side. The right side of the chemical equation is the product side. What is made, what is produced throughout this reaction. So we're going to model what I have right now. I have 1 Al. I have 2 oxygens. Notice how they're stuck together. They're bonded. Okay? And then I have 1 Al2O3. Again, notice how all those atoms are bonded together. They're stuck together. Now I need to see, does the left side match the right side? I got one yellow here and two yellows there, so it doesn't match. But I can add another Al here, and now my yellows match. But my blues do not match. I got two here and three there. So wouldn't it be great if I could just put one oxygen right here and then it would match? But I can't do that. Very important part here, guys. I have to use this formula, O2. I can't, it's just not one single O, it's O2. So I have to bring up a pair of oxygen like that. So now I have 4 over here and 3 over there. Again, it would be great if I could just pull up one oxygen, but that's not what the formula says. The formula has 2 Als and 3 Os bonded together. So I have to pull up another one of the whole formula. Okay, now that gives me 6 blues here and 4 there. So if I pull up another pair of oxygen here, then my blues match. 6 blues, 6 blues. But my yellows are off. I got 2 here and I have 4 over there. But if I pull up, whoops, 2 more Als here, then I'm balanced. 4 yellows, 6 blues, 6 blues. Now I'm balanced. The next thing I need to do is write my coefficients. What are the numbers that go up here? How many of each did I use? Well, if I count my aluminums, I used 1, 2, 3, 4. So I have 4 aluminums. If I count my O2s, we're not counting individual oxygens here. We're counting the group, the O2. So I have 1 O2, 2 O2s, 3 O2s. So I have 3 O2s. And then finally, how many groups of Al2O3 do I have? And I have 2. So there you go, guys. You have officially balanced this chemical equation. All right, moving on to the next example. Again, I know the left side are the elements I'm putting together. They're going to react, and they're going to create or produce the products. I'm going to pull up the models. This is the whole chemical equation. Remember, chemical equations are made up of chemical formulas. So I've got 1 CuCl2, 1 Al, 1 AlCl3, and 1 Cu. And now I want to balance these. Well, my yellows are good, my oranges are good, but my greens are not. There's 3 greens here and 2 greens there. So can I just pull up 1 green and be balanced? No, I cannot. I have to pull up the entire formula. So I have to pull up another CuCl2. And that makes 4 green here and 3 green there. So my green aren't balanced. Again, if I could bring up 1 green, then I could be balanced. But I can't pull up 1 green. I have to pull up the entire formula. So if I pull up an entire formula, I see 6 green here and only 4 here. But if I pull up another one of these, then I have 6 green and 6 green. So my chlorine are balanced. Now let's see if we can get my Cus balanced. I got 3 there, but only 1 here. So if I pull up 1, 2 more of those, then my orange are balanced. And the last thing I need to do is balance my yellows. So I have 2 yellows there, and now I have 2 yellows there. All right, so now we are balanced. Now let's count our fabulous formulas, so we can see what our coefficients should be. So I've got 1, 2, 3 groups of CuCl2. I've got 1, 2 Als. I've got 1, 2 groups of AlCl3, and I have 1, 2, 3 Cus. So now I am balanced. Yay! All right, moving on. Next one, this is one I want you to try. So I'm going to go ahead, and first of all, I'm going to pull up one model of each for you here. So one of those, one of those, one of those, and one of those. All right, so now I want you to pause the video, and I want you to try to do this on your own. And then unpause the video when you're finished and check your answers with mine. All right, pause the video. All right, let's see how your answers are. See if you match mine. So I've got 4 H's here and 2 there. So I'm going to pull up another one of these. That gets me 4 and 4. So I'm good there. But I got 2 browns here and only 1 brown there. So I'm going to pull up a whole CO2. So now my 2 browns match my 2 browns. My 4 purples match my 4 purples. But my blues are messed up. I got 2 oxygen here, and I got 1, 2, 3, 4, 5, 6 over there. So if I pull up 2 more of these, then I should be balanced. 6 blues, 4 purple, 2 brown, 2 brown. So I'm balanced. So how many C2H4s? 1. How many O2s? 3. How many CO2s? 2. And how many H2Os? 2. All right, very good. Moving on. Here's another one you can try if you'd like. All right, last thing we're going to look at right quick is balancing the masses. So remember, the law of conservation of mass says that matter is neither created nor destroyed. So if we know that the left side over here, I know this left side right here is the reactant side. And so if I add the 45 plus the 10 together, then I know I have a total of 55 grams of material on the left side. So knowing that, what should I have on the right side? It should be equal. It should be exactly the same. So the right side should also add up to 55. So in order for it to add up to 55, I need to think about 20 grams of CO2 plus what of H2O is going to end up getting me 55. So I can subtract 55 minus 20, and I should end up with 35 grams. All right, test yourself right quick. See if you can do the next 2. Pause the video and then check your answers with mine. All right, let's see how you did. So the left side should equal 12 because both sides should equal 20. 20 over here, 20 over here. Again, on the last one, if the right side's 70, then the left side has to be 70, which means H2 has to be 20. That is balancing masses, guys. Left side has to have the same mass as the right side, according to the law of conservation of matter. All right, last thing, just a review. I know the law of conservation of mass states that matter cannot be created nor destroyed. So we're going to be doing some more of this, practicing this. Y'all holler at me if you have any questions. All right, bye.